This is the Solid Signal Podcast for the week of September 10th, 2018. Welcome. This week I wanted to get back to basics, do a kind of an old-fashioned technical podcast. I tend to ignore doing those, and I probably should do more of them, so I apologize. And I wanted to talk a little bit about signal loss. Signal loss, my friends, is inevitable. It's like death and taxes. It's something that you can't ever avoid, and the best that you can do is manage it. You know, signal loss is one of those things that happens when an electrical signal goes over a cable. The cable has within it resistance. It's not perfect, and the material, even if it's the best conducting material ever, has a tendency to resist the signal that's going through it. Think about it this way. If you were walking through a swimming pool, and it's shallow enough that you can walk through it, walk back and forth, you're going to get tired. That's because the water is resisting you. Now, you could get really strong and you could exercise and you could get to the point where it doesn't make you as tired, but that's not going to stop the water from resisting you, and it's also not going to stop the fact that eventually you're going to get too tired to go any further. That's just how that works, and that's how signal loss works. It is something that you cannot avoid. Everything you add to a cable run, for example, a splitter or diplexer or a combiner, increases the amount of loss. And when I say loss increases, I mean that signal decreases. They kind of mean the same thing. And that's what's really important, because eventually you get to the point where the signal is so weak that it can't be distinguished from the noise around it. And that's when you have problems with your video picture, or you can't hear the signal from your sound system, or what have you. Signal loss happens in every system. It is just inherent to the way that we broadcast. It happens when you broadcast over air. It happens when you do it over a wire. It happens whether the signal is digital or analog. It just always happens. So what you have to do is try to figure out how you're going to deal with signal loss, and if it is indeed even possible to deal with signal loss. Let's talk first about satellite, because satellite is something that drew a lot of people to the Solid Signal blog and to this podcast. Even though not everybody is staying with satellite TV, I understand there's a lot of cord cutters out there. But when you talk about satellite TV and modern satellite TV systems, there is practically no way to deal with signal loss. I know this may seem kind of, nonsensical. After all, we get more modern, and all of a sudden we don't have the ability to deal with this sort of thing. It used to be fairly easy to deal with satellite TV signal loss by adding an amplifier, but today's two-way systems are simply not designed for it. It's not impossible to do. It's just that satellite TV systems today are sort of designed for more residential setups where really you just need enough signal to go about 300 feet in any direction. And so there really doesn't exist a system that will let you amplify a satellite signal once it gets into your house. If you are inclined, you can amplify the signal between the dish and a multi-switch, but once it gets through the multi-switch, there isn't much that you can do about it. So the best thing to do is plan to put that multi-switch right in the middle of your setup, and then you can run between 150 and 300 feet from it, depending on what you're doing. I've got some diagrams and stuff at blog.solidsignal.com. Check out the tutorial section at the top, and you'll find a whole bunch of stuff. So planning ahead is about the only thing that you can do with satellite. On the other hand, things look a lot better for antennas, because with an antenna, it's not really a two-way system, so you can continue to amplify as much as you need. Digital broadcasting doesn't benefit from amplification in the same way that analog broadcasting used to. So an amplified antenna isn't necessarily going to be your be-all and end-all answer for everything. But what it is going to let you do is it's going to let you compensate for a long cable run. For example, putting your antenna up higher on a pole or on a mast or on a tower, and then running into your home. It's going to let you compensate for the fact that you're going to have 5 TVs in the house attached to the same antenna. It's not going to necessarily give you a whole bunch more than that, except in specific situations where the noise itself is fairly close to the level of the signal, and therefore sometimes it's possible to just get a little bit more out of that signal than you were previously expecting. I should mention when it comes to computer data that amplifiers are almost completely unknown. And this is just the nature of Ethernet and the way that it goes through wires, that really you just have enough run with Ethernet. I mean, you get 400 or 500 feet from Ethernet and it's just not a problem. And from there you can put in another router and it's going to reshape and renormalize the signal and get you ready for another 500 feet. So inline amplifiers for that sort of thing are hardly ever seen. On the other hand, you do have strong amplifiers in wireless, and they're just built into access points. That is essentially what an access point is just really kind of an amplifier for Wi-Fi signals. One more thing I want to mention, and then this relatively long podcast is probably going to be done, is cellular, because cell phone signal boosters are essentially extremely complicated amplifiers. It's interesting that even though cell signals are digital and TV signals are not, that cellular signal boosters work a lot better as amplifiers where TVs do not, because a cellular signal booster is really, in a lot of ways, it's bringing signal from outside in addition to amplifying it. It's reshaping that signal, and so signal boosters tend to be much more expensive than traditional antenna amplifiers, and that means that they're capable of doing a lot more tricks. So what's the moral of the story here? The moral of the story here is that signal loss really is something that in a lot of cases you can't deal with except through proper planning. It's not that there are necessarily technical limitations that stop you from doing it. It's that the devices to do it are really, really special purpose in a lot of cases, and so they just aren't built, or they aren't built at reasonable prices. So it comes down again to the idea of planning to avoid signal loss instead of having to deal with it on the fly. I should mention, because this is a technical podcast, that a lot of parts, a lot of the amplifiers that are available, cellular signal boosters, Wi-Fi access points, antenna amplifiers, and trunk amplifiers for satellite, are available at solidsignal.com, and I would appreciate it if you would at least check out the selection over there, as they do kind of keep the lights on for me, pay my salary, and keep this podcast going strong. That's about it for this supersized podcast. I hope you have a great week, and I'll talk to you next week.